3.
All right, well, good morning, everyone. I was asked today to start with a special presentation about severe weather forecasting. And we do have, off in the Pacific Northwest, a few areas of marginal risk. So I thought I would just run through my forecasting. I'm not a professional weather service or storm prediction forecaster, but the kind of process that I teach my classes, I figured I would go through. Looking at first New Jersey, where there's no thunderstorm risk according to the SPC, so we'll see why that is. We'll look at around Wilmington, North Carolina, where it's general thunderstorm risk, but the SPC discussion mentions maybe they'll upgrade to a marginal risk later today, so we'll see just how marginal that is, and then we'll look at a third area here in the Pacific Northwest where there actually is a marginal risk of severe weather in the forecast. So when it comes to, first, just thunderstorm forecasting in general, the ingredients methodology says you want to look for 3 ingredients: lift, moisture, and instability. And there are a variety of ways of assessing those 3 ingredients. Since we're looking at daytime convection, often the lifting mechanism would be some sort of surface boundary, a front outflow boundary, something along those lines. So I pulled up the current surface map analyzed with the fronts here from the WPC, and we do see that area of convection forecasted by the SPC in the southeast. There is a front there, looks like pretty much a stationary front with lots of waves of low pressure moving along it. That front is out ahead of a very broad trough over the east today. This is the current 500 millibar map from this morning. If we go to the sort of northern Great Lakes area, there's a little blob of convection threat there. What's the lifting mechanism in that region? Well, it does look like there is a front diving down out of Canada. That may be the lift that's needed to spark off convection there. Notice here in New Jersey, and really the Northeast in general, we're under high pressure, not really any clear lifting mechanisms of any import. There was a blob of convection here along the mountains and also perhaps along the sleet trough. So in that case, it's probably orographic lift for the most part, but maybe the sleet trough as well. And then our marginal risk, we do see another trough in the area. We certainly have mountains, so there's probably orographic lift occurring as well. But we also have a shortwave moving in, according to the analysis here, especially into Washington. And that may help destabilize the atmosphere there. And so let's go to the instability and moisture ingredients. I have on this picture here a sounding from New Brunswick indicating the lack of all of our ingredients. We already said there's no lift present. What about the instability? Well, according to the rapid refresh, and I'm looking at the forecast valid later this afternoon around the time of peak heating, we do see, despite a pretty extensive layer of clouds that's present and doesn't seem to be leaving New Jersey anytime soon, the rapid refresh is indicating we should heat up this afternoon and get a nice well-mixed boundary layer, as you would expect in the summertime, especially under sunny skies. We'll see if this actually materializes. But above the boundary layer, we have poor lapse rates. So the instability just isn't there. You can see these tiny numbers in the lower left are all right around 5 Celsius per kilometer. That's just not quite going to cut it. And therefore, you can see our parcel path here, the dashed line is not showing much, if any, CAPE. There's just a little bit of 1 to 5 joules per kilogram of CAPE there at the top of the boundary layer. That's not enough to give us convection. You can see the boundary layer is relatively dry. We only have low 50s dew points. Presumably the model, so right now the dew point is 56. I just checked here in New Brunswick. Presumably as the day goes on, we get some mixing of some drier air from aloft down into the boundary layer. Our dew point should go down to the low 50s. There's plenty of moisture aloft, so actually the model is picking up on all that high cloud, but it's for whatever reason thinking the sun is really going to get through that high cloud and warm us up at the surface. We'll see if that happens. But regardless, there's just not enough moisture in the lower troposphere. So we don't have the moisture, we don't have the instability, we don't have the lift, therefore no thunderstorms here in New Brunswick or New Jersey or really the Northeast today. But if we switch to the Southeast, and let's go to somewhere around Wilmington, I guess it doesn't really matter which one I click on here. This is a region where the SPC said there should be some thunderstorms in the area, but maybe not severe. It's kind of questionable if this is a threat high enough for severe thunderstorms. So in this case, oh, I should have deleted the previous profile. So ignore the purple and look at just the green and the red. First of all, we see the moisture. We're now very close to the front. And so the dew points are way up in the 70s in the RAP forecast. We have an extremely moist boundary layer all the way up to basically 100 millibars at this station. So moisture is not a problem. Our lapse rates slightly better by only a tenth or two aloft, but with the moisture, these lapse rates are enough that we do have some CAPE. It varies depending on what parcel you choose. I like the mixed layer parcel. It's only 328 joules per kilogram. So that's on the low end. And this is really the inhibiting factor that the SPC mentions in their discussion. There's a lifting mechanism. The front is nearby. There's plenty of moisture, but the instability is a bit questionable. If enough sunshine gets in, maybe some of that vorticity advection in front of the trough cools the mid-troposphere, maybe we'll get a little bit more instability. These lapse rates will increase a little bit above what the RAP is indicating, and that will, just a small increase in the lapse rates could have a pretty large impact on the CAPE based on how skinny the CAPE is right now. That's also indicated by a relatively small lifted index. So with a little bit more instability, we could have the risk go up quite a bit. We're not going to go to a high risk, but we might go to a marginal risk. We do have, so when we are looking at convection is present, or the ingredients for convection are present, then the fourth ingredient we bring in is the wind shear to assess the possibilities of severe convection, the mode of that convection. And in this case, we have a kind of a topsy-turvy sounding here with lots of veering just north of the warm fronts. We're seeing lots of veering in the sounding. So we've got nice storm relativity and decent 0 to 6 kilometer shear, not quite up to supercell range, but certainly a multi-cell type convection would be expected with this kind of shear profile. So really the only missing ingredient is some stronger instability. If that instability does materialize a little bit more than the RAP indicates, then we could get some marginally severe multi-cell type convection there in the southeast along the coast. Finally, let's go to Washington State. Somewhere around Yakima or Wenatchee seem to be in the marginal risk. So what's going on? And maybe out there, we should go to 0Z. Oh, I should have cleared. Hold on. Let's get rid of these profiles. Remove. All right, I'll get rid of the other one once I add something. All right, looks like this time I cleared it out anyway. So here we have sort of a typical Western US severe profile where we have a very dry boundary layer. So you may be saying, you know, where's the moisture? How are we going to get severe convection out of this? But the idea in this case is really we're getting, with these fairly steep lapse rates, you can see the numbers here much higher than they were in the east. So we have the instability present. We have this extremely deep boundary layer. So this inverted V-type sounding, what that allows for is this high base convection, where you can see our LCL is way up around 650 millibars or so. And so we have this high base convection, and it generates evaporative cooling. There's lots of dry air if convection is able to develop. And somewhere down here, I think you can see a downdraft. Yeah, so the downdraft CAPE, 1433 joules per kilogram, much higher than the updraft CAPE. So as long as we get some downdrafts going out of that high base convection, combined with the dry air and the very steep lapse rates in the boundary layer, we could get some negatively buoyant air parcels all the way down to the surface. These dry microbursts could occur. So as long as we have the lift from perhaps the mountains in the area, just enough moisture that we have some CAPE present, given these very steep lapse rates. And in this case, we also have decent wind shear as well. Again, we're in that kind of multi-cell range, but the key is this inverted V sounding, the huge downdraft CAPE. And so probably the primary severe threat would be damaging wind gusts with downbursts. Let's confirm that by going to the particular threats here. So you can look in the Pacific Northwest, and indeed wind is the only threat. Tornado and hail, nowhere is that a problem today. So presumably Oregon would look quite similar. Any questions about today's severe weather, or just thunderstorm in general situation, before we turn our attention back to the 16 to 20 day range?
I have a question or two, but I just want to see if before I jump in, does Michael or Dave D'Arcangelo have anything?
I'm good, Dave. I'm good, Dave. Thanks, Dr. Decker. Appreciate the rundown. It's always, I just want maybe one comment, which is that it's always remarkable as we kind of shift into the second half of summer how I guess relatively benign things always start to look. Obviously not a surprise, but you get these kind of every day is kind of a marginal at best day.
Right.
With lack of really significant shear, with lack of cold air, sufficient cold air aloft. It's just it always feels like we're parsing it out. Marginal events.
Right.
So Dr. Decker, I have three general questions, and they're more macro questions. And on any of these, feel free to pass, because we certainly didn't prep you with these questions before. So I'll lay them out one at a time, and then I'll lay the three questions out, and then you can answer in whatever order you want. So the first question I had was regarding climate change. So we hear a lot of, all the time, right? We talk and hear about studies about how global temperatures are changing and things like that. We hear a lot about, or I hear a lot about the tropical cyclone activity and what influences climate change might have on that. I hear less, although I know there's some studies on severe weather. I was wondering if you could comment just in any information about how climate change, at least in the United States, how it is or may in the future influence the, frequency or patterns across the United States. And I'm asking this sort of with my financial weather committee hat on. Because obviously the insurance companies, whatever, that there's certain areas that are, more, where you see more of the activity and are more at risk, at least based on historical information. But, is that going to be a reliable indicator for the future? So that's my first question. My second question was more, I'm just curious if you can talk about the seasonality a little bit of it. Again, I'm trying to think back to my old classes and stuff. And of course, I think the springtime in the United States, of course, is the most active, but I think the fall tends to be a secondary sort of active season. And this relates to sort of my third question, which is, more specific to New Jersey. I think we know anyone who lives out in this area, Pennsylvania, New Jersey, New York knows we don't get the kind of severe weather we get, across the middle part of the country. It's not as severe, probably not as frequent. Again, just from a macro sense, not super details, but can you, talk a little bit about why the conditions that are favorable for, some of the more severe weather, whether it be severe, tornadoes and hail outbreaks that, are necessary and facilitate in the middle part of the country, and what's missing in the Northeast, i.e. why don't we have that kind of setup? Is it the temperature? Is it the lack of humidity? Is it the lack of upper air support? Is it the lack of all these kind of conditions coming together? But what's the primary differences between here and there? So those are my questions.
Sure. So starting with climate change, I haven't looked too recently at any of the latest research, but what I can recall from looking in the past is there's some conflicting factors at play. Certainly the moisture ingredient should increase in a warming world, but at the same time, the wind shear ingredient, to the extent the wind shear is driven by thermal winds, where the pull to equator temperature gradient drives that vertical shear. And if that's decreasing because the pull is warming faster than the tropics, then overall, perhaps the wind shear should decrease, but the moisture should increase. So those are conflicting signals. And so I think the jury is out. It may depend on exactly where you look. Some areas, maybe that moisture is the inhibiting factor more than the shear, and vice versa. Some other areas, maybe there's so much shear climatologically that even if the shear is reduced some, it's still good enough. But so there are these conflicting signals, and I don't think there's any clear answer about just what to expect in terms of the impacts, at least if you look at the nation as a whole. In terms of, I remember your third question, why is New Jersey not so, okay, your second question was the seasonality. So we have, the spring is sort of the heart of the traditional severe weather season. That's because we have our cold air aloft is still present, our shear is still present, yet we're getting strong sunshine, and so we're heating the lower troposphere, so we get the steep lapse rates in the springtime. In the fall, the mid-troposphere still tends to be relatively warm, right? It has that residual warmth from the summertime, but we get the shear back. So the shear is what's really missing right now in the middle of the summer. So you get that, especially in the central US, there's a bit of a resurgence, not nearly to the extent that it is in the spring, but there's that secondary maximum in the fall. I think that's primarily associated with the shear returning before the warm air at the surface completely goes away, and hence the instability. But the instability tends to be less in the fall because the middle troposphere isn't as cold as it is in the spring. And then in terms of the sort of the seasonal cycle for severe weather, why is the spring season so active in the Central Plains, but we don't get much in New Jersey, especially when our severe weather season in New Jersey and the Northeastern Journal is a bit delayed. It tends to be more summertime as opposed to springtime. There isn't much of a season to begin with, but to the extent we had one last week, we had a nice event in the climatologically favored midsummer period for us. What's going on, especially for us in the spring, there's two factors, I guess. One is sort of year round, and that is one of the ingredients is instability. And you can really maximize the instability in the central US by advecting these elevated mixed layers from the desert Southwest into the middle troposphere over the Central Plains. You get these steep lapse rates of almost 10 Celsius per kilometer in the middle troposphere over the Central Plains. It is pretty rare to get those elevated mixed layers to advect all the way to the Northeast without them being modified by convection on previous days before it gets to us. So we tend to have less instability. Our lapse rates, we almost never see a 9 to 10 Celsius per kilometer mid-tropospheric lapse rate in New Jersey. And then the other factor is for, especially for the tornado risk, where we're looking for storm relative felicity, a lot of circular or semicircular hodograph shapes. If we have westerly winds aloft, to get a nice semicircular hodograph, that typically would imply south to southeast winds at the surface. And in New Jersey, a south or southeast wind in the spring is coming off of the cold Atlantic Ocean. And so that further reduces our instability. So we might have a great wind profile, but no instability because we have relatively cooler temperatures coming in off of the ocean, especially in the springtime. So those are some of the inhibiting factors for us in New Jersey. I think that was all the questions.
Yeah, that's
Did I get them all? Okay.
You did. Thank you.
Mm-hmm. All right, so let's look at what happened during our last verification period. Let's look, here's the map, and then we'll see what the number was based on this map on the forecast website. So we do see kind of a warm northwest and southeast and a cold southwest and northeast. And averaging all this out, especially considering there aren't huge populations where it's warm here in northern Idaho, this turned out to be pretty close to climatology in terms of the net CDDs, population weighted for this period. So if I go to our verification here, we see, I guess at the very bottom, no, I sorted. So verification is somewhere in here. Here it is. So 58.4 is the verification, the 30-year normal 58.2. So 0.2 CDDs above normal. So the warmth did win out ever so slightly. When you have a verification very close to normal, the only way to get a positive skill score is to have your sigma less than climatology, certainly it's hard to beat the actual value compared to climatology. And so if I sort by our skill score, we see it looks like our one human forecaster who was able to get a positive skill score in this case, Dr. Lupo, he was able to correctly sort of emphasize that it's going to be close to normal, right? His forecast was almost climatology for the mean and a reduced spread, indicating a greater chance than normal of normal conditions, if that makes any sense. So he got a slight positive skill score. Everyone else was in the negative to various degrees, I guess, depending on just how far away from normal. So we can see some forecasters that were very warm and had very negative skill scores as a result. I was following the CPC as usual. They look to be a little cooler. And actually, let's see if I look at my map here, right? So CPC accurately indicated it's going to be warm in the Northwest. But the cold was a little bit misplaced. It was more south central US. Whereas if I go back to the map, there was some in Texas, but it was West Texas and really into the Southwest. And what was missed in the CPC forecast was this cold Northeast and warm Southeast, but that kind of canceled out in the end. In fact, even our top forecaster I saw, Dr. Lupo, if we look at his forecast map, it does not have the warmth in the Southeast. It did have the cold in the Northeast. So the warmth in the Southeast seemed to be a surprise. Let's close some of these. Just do a quick run. Did anyone have warmth in the Southeast in their forecast? I don't think I saw warmth in the Southeast, but let's just double check. Oh, Dave, you had warmth in the Southeast, but you had warmth in the Northeast as well. Anyone else? Matt Lanza was just warm everywhere. So the cold in the South, the cold in the Northeast and or the warmth in the Southeast, that was where things went awry. But they kind of canceled each other out, it seemed like, in the overall results here.
Yeah, Dr. Decker, I'm gonna cry foul on that. That's David Margolin that set those geographic boundaries up based upon the EIA numbers.
Right, yeah, the East kind of covers both the cold and the warm, so it's hard to.
Yeah, so I want to get. I get zero credit where I'd like to argue for partial credit.
All right, so let me close all these maps I just popped up. So how did the models do? We can see the CFS, again, was too cold, just a little bit compared to verification, whereas the ECNWF was a little too warm, but I guess it was a little bit closer. And so it got a skill score that wasn't quite as negative as the CFS. And this follows, I think, let's just verify that for the entire season. If we look at the bias, we see the CFS has had, as it was the case last summer, if I remember right, this persistent cold bias, the most negative bias amongst anyone, whereas the ECMWF is closer to no bias. You look back to last summer, and that was the case as well, because very negative bias. But what do the maps look like? So this is a CFS forecast. It's not exactly the right dates, but it's the closest, I guess, that we have. So the CFS indicated a trough just off the East Coast, and then this positive height anomaly over the West, extending down into the Southeast. ECMWF also had a trough, but over Canada instead of off the East Coast. It had the positive anomalies over the Northwest. Doesn't extend them quite as far into the Southeast as the CFS did. The resulting 2-meter temperatures. So CFS seemed to handle the West very nicely with the warmth in the Northwest, the cold Southwest, and even a little hint of cold in the Northeast, the CFS forecast, and a hint of some warmth in the Southeast. Doesn't look too bad. I guess it's just that cold bias was the main factor here affecting the CFS. Looking at the ECMWF, again, the West was pretty good, but there was a little bit of warmth in the ECMWF or at least off the coast. In the Northeast, no sign of the warmth in the Southeast. So at least based on the 2-meter temperatures, I would give the qualitative win to the CFS, even though they had the lower quantitative score. I'm going to say probably because of that cold bias. But looking at these maps, it seems like the CFS is a little bit better, not accounting for any population weighting. What about this pattern aloft? So let's look at what actually happens. I think I can go back here. Let's do our 500 millibar. Oh, I have to change this, right? Global, let's do global. Height departures, same dates. Look at the map. This must be an edge bug, or I have to click this a few times. All right, so we do see, whoops. We do have this negative height anomaly, probably stronger than what was in the model, situated right over New Brunswick, Canada, it looks like. So it's right in between. CFS had it a bit south of New Brunswick, Canada, and ECMWF a little bit north of New Brunswick. Kind of average that together, it's pretty much in the right place. Ridge in the west, again, the CFS did have it extending into the southeast somewhat, or at least the south central US. What actually happens? We did have a ridge over the west, and it was it did extend towards the southeast. So again, qualitatively, at least looking over North America, certainly the rest of the world, there were some big misses, but at least over North America, both models did a pretty good job. And I would even give the edge to the CFS again, based on the pattern. So similarly to the last time I led the discussion, it seems like the CFS had the pattern a little bit better, and yet was not rewarded in the scores. I'm assuming that's due to the cold bias that's in the model. So it'd actually be interesting if we introduced some sort of bias corrected CFS and saw how that performs, because it does seem like the pattern, it's doing a pretty good job, despite the negative skill scores. So the models did have this, maybe not as strong, but it did have this negative height anomaly over the northeast, consistent with the colder temperatures that were present. But despite that, many of us didn't really forecast that cold based on the maps. Again, it's tricky because the east region kind of covers both the cold and the warm. But the models seem to pick up on it to some extent, maybe not to its full extent. So in this case, since the models did a pretty good job overall, it's just hard to beat climatology when that's the verification. I couldn't think of anything to really dig into beyond that. So I don't know if anyone else has any comments on what happens in this past period before we move on to the forecast.
I guess just a couple comments. I just looking at the broader skill scores for the summer thus far. It's just interesting that the MGO analog tool, I think, is performance versus consensus. Yeah, performance versus normal. It's one of the top, especially with a minimum of 9 forecasts. I guess you could say Matt Lanza is up there, but 5 forecasts. He picked a good time to stop. I don't know. But we've talked about this for the last few weeks, Dave and I in particular. It's just interesting again that the summer, it seems like the level of difficulty, I guess speaking in Olympic terms here, right? The level of difficulty this year seems like it's gone up quite a bit from last summer. I was looking back in the directional hit rate and stuff like that from last summer. A lot of us were in the 80s. Most of us were at least in the 70s. In terms of directional hit rate, whereas this year, Dr. Decker, I think you have one of the highest, if not the highest, in terms of human hit rates. But a lot of us are in the 50s and 40s and 50s, having a tough time beating the 30-year normal, which again seemed like up until this summer seemed like heck, we were even talking about saying is the 30-year normal too easy? Maybe we should change our benchmark to the 10-year normal. Well, I'm glad we didn't do that this summer, because I think some of our scores would even be worse. But again, so and more broadly, we've talked a lot about. So we don't necessarily have to do this again, but we've talked a lot about how the summer just changed a lot, at least in terms of CDDs relative to normal, national CDDs relative to normal from June to July. where June record high, July very close to the 30-year normal. And I think there's a lot of interesting just tidbits in terms of, looking in the future, maybe some studies trying to understand what caused that CDD shift, better understanding the CDD shift. Was it a fundamental pattern shift in the atmosphere, or was it just something more subtle, and stuff? So we've debated that a little bit. And then just final thought, but this segue more into our forecast. Obviously, there's some interesting forecast things going on, which I'm sure Dave Dark Angel is grappling with. It looks like I happen to be looking at the 6 to 10 a little bit more than usual because we're actually going to go to the beach next week. And it looks like finally, maybe we're going to get some of that heat back, anomalous heat, I should say, back into the eastern states. So I think that's going to be an interesting conversation when we turn to our forecast here to say, hey, is this more of a blip, in the 6 to 10, 11 to 15, and then, more variability in the 16 to 20? Or is it, are we going to go back to something, more of a common sort of summer theme here with a lot more heat in the Midwest and East? Persistent heat, I should say.
All right, thanks for the comments, Dave. So let's turn to the forecast, and I guess I'll start as usual because I'm just doing the CPC forecast. Here it is, and they're indicating pretty much the same thing they've been forecasting all summer, although the heat in the Pacific Northwest is reduced compared to earlier in the summer, but we still have this general pattern of warm in the north and cool in the south. But in this case, whereas earlier, a few weeks ago, the warmth was kind of winning out. Here we have 60% probabilities covering a fairly all of Florida, I think, unless that's a line there that I didn't see before. Heavily populated areas across the Southeast, whereas the highest probability of above is not a lot of population right along that Canadian border. So I went slightly below normal when I sort of did my qualitative population weighting to this map, but just slightly below normal with my forecast based on this. I thought it was interesting. So I'll show my forecast. I thought it was interesting in the discussion that I highlighted some pretty good consistency in the dynamical models, which we'll take a look at. But they also mentioned cool SSTs in the Gulf of Mexico played a role in their forecast. But when I went to look at the SST anomalies, I'll do the weekly so it's smoothed out a little bit. It actually is warm in this analysis anyway. But I was thinking maybe it's a different base period. This is still an older base period in this map, and maybe I'm assuming the normals have warmed. And so maybe this area that's above normal relative to this base period is actually below normal relative to the new base period. I'm not really sure, but it seems inconsistent with what the CPC was basing their forecast on. So that was kind of interesting to note. That's a little maybe fly in the ointment to the CPC forecast. I'm not sure. While this is up, I guess we still see the Atlantic Nino seems to be going strong there in the Eastern Equatorial Atlantic. That's a negative phase of the Atlantic meridional mode, where it was cold in the subtropics in the north and warm in the subtropics in the south. That seems to have gone away. It looks pretty much neutral at this point, although the tropics are still relatively quiet. I guess I don't have it up, but last I checked, I guess there's a small disturbance with pretty low probabilities just emerging from Africa, but it's remained quiet in the tropics over the last few weeks. All right, so I was going to look at those dynamic models. Since the CPC forecast mentioned some good agreement there, so let's verify. That was on Friday. Things can always change. So let's go to the current map. So let's do the 2-meter departures. And so we see the most recent ECMW front does agree, at least in the south for the most part, and in the west and north central with the heat. What's disagreeing is some of that warmth in the northeast. The ECMWF says no, the 6 to 10 to 14-day range, it's going to flip back to cold here in the northeast. And if we look at I'll average the last 4 runs of the CFS, pretty similar. In fact, the warmth has actually shifted more into Canada, and the cold is expanding into the west. So we still have this cold to warm pattern, but it's kind of shifted north, and there's definitely more cold. This could be that cold bias again in the CFS rearing its head. But if you kind of blur our eyes, it's kind of similar. Especially the average of the average of the last 4 runs and the most recent run are pretty much the same. So there is some model consistency here, except over sort of the northern New England region, especially if you kind of account for the cold bias of the CFS. So that's matching up fairly well, except for some of these mountainous areas in the west with the PC forecast. The final thing I was going to look at was the MJO, because they mentioned that in the PC forecast as well. It's been active, although not super amplified lately. There it is. So I guess can I blow this up some? There we go. So you can see over the month of July, we did complete a circuit basically of through almost all the entire phase space. We started the month around phase 1, 2. We finished the month in phase 8. Fairly low amplitude for the most part, but certainly a coherent signal. And the forecast is for the MJO to continue to progress through phases 8, 1, and into 2, and stay at relatively low amplitude, but outside of the circle here. For the most part, there's certainly some ensemble members that are indicating less amplitude. CPC indicated whatever tools they're looking at for the 3 to 4 week period was indicating a weakening of the MJO into the circle after this period. So we'll see if that happens. But based on the analogs, so right now we're in phase 8, relatively low amplitude. The analogs would indicate some warmth. So countering the CPC, which I indicated was a little bit below normal, looks like the analog should be a little bit above normal based on these results here and the current state. And so indeed, if we go to the forecasts, so let's switch to the current forecasts. And let's sort by the mean here. We see the MJO analog slightly above the normal. So going slightly warm, whereas I went slightly cold based on the CPC forecast. We do see, as those CFS maps indicated, it's quite cold, probably that cold bias at play. ECMWF is actually the warmest forecast of anyone today. So with that, would anyone else like to discuss their forecast?
Yeah, sure, I can go. So I wound up with a value of 50.8 with a spread of 6.5, decided to lower it a little bit based on, the last couple of verifications indicating that, and this was a discussion I believe we had with Dr. Lupo I think it was last week, where it seems like a pretty good bet to have your forecast be somewhere between the 10 and 30-year normals, and it doesn't really deviate too far from that. And I think especially the last verification really highlights that as well. So I decided to lower my spread a little bit to kind of account for that. So I started off though with as I always do, with a value of 54.25 by blending the EC and 10-year together. With 70% weighting on the 10-year and 30% weighting on the euro. And that got me to 54.25. Then I decreased my value by 3.5 based on the CPC forecast, as Dr. Decker's already pointed out, a lot of cold in the south and not too much warmth in any populated areas. I also took a look at the teleconnections. Nothing really stood out to me in the 15-day range, although interesting to note, the PNA is extremely positive right now. I think it was 3. Yeah, it looks like about 3 positive on the charts, which was a little bit of a surprise to me. I'd been seeing that was the forecast the past couple of weeks, and didn't really expect that to verify such an extreme, but didn't seem to affect the forecast too much. despite it being so positive. So I didn't really factor that into my forecast. Seems to be going back down towards neutral anyway. So once again, didn't make any changes based off the teleconnections. And that's pretty much it. Any comments, complaints, questions, or concerns?
Sounds good. I have no questions.
I don't have a question specific to that, but I did, Dr. Decker, I was wondering if you could pull up the SST map you had. It really jumped out to me. Yeah, the one, yeah, one of those. Exactly. And this question, I guess, for anyone in the group, but was thinking in particular, Dave D'Arcangelo, you know, and I remember in the University of Albany thread, them talking about the warmth of those, the anomalous warmth of those SSTs in the North Pacific. It just really jumps out to me. I haven't looked at any studies on this, whatever. I don't know exactly what those levels are, but they look like, it looks like the beginnings of, like, you know, a Godzilla movie or something. Like something's going to come from that, you know? So does anyone have any thoughts in terms of what this means, if anything, for weather, or you know, the climate patterns over the next 3 to 6 months? You know, are people speculating about, you know, certain, how this might influence the winter patterns, or, you know, or anything like that? Does anyone have any thoughts on that?
Hey, Dave, there's been a little chatter about that in the in kind of the Twitter sphere with regards to energy. And it seems like there's not much concern because of the location of where that anomaly is. If you located it maybe 15 to 20 degrees longitude farther east, you'd be in a much more statistically significant spot. You know, the impression that I think people have is that, you know, that region can move, or its anomalies can change remarkably based upon the weather across East or Northeast Asia. So it's not seen as kind of a potential. It's different than like an ENSO signal or something you'd see in kind of the Central East Pacific versus the region that it's located. So not a concern yet, but the further that, now we're dealing with a Western Pacific blob. You know, for a number of years we had the East Pacific blob that got some notoriety, but this one is not seen as potentially as long-term stability.
I wonder if any of this is, I know there have been lots of wildfires in Siberia. And I'm just wondering if there's, like, you know, an anomalously warm air coming off of the continent into that area. And so it's not cooling, you're not getting the sensible heat flux that you would expect. I don't know.
It's a good question. And we know it's been a very quiet West Pacific tropical season so far. Really seen very few systems, and the few that we have kind of tended to meander kind of south of Japan. So maybe it's the lack of tropical activity causing some upwelling. I don't know if that's like a real thing or not, but it's just, you know, I'm just throwing that out there as well. You know, I'd have to look into maybe if that is so, or why it would be.
It certainly is interesting.
Okay. Yeah, I mean, I think that's fair. It could be just, I know, channeling my inner Professor Roundy, I know he used to talk about a little bit that, yeah, that those SSTs are obviously, anomalies are further north, so that absolute temperatures obviously are not going to be the same as if they were over the equator or something like that too, which ultimately influences, you know, the amount of heat transfer and stuff like that too. But I guess it's something anyway to watch and see how it evolves over the course of the next few months. I mean, if it did shift eastward, like Dave was talking about, like if that happened, it sounds like it could be in a more statistically significant area.
One other thing too is there's been this kind of stubbornly persistent extension of monsoonal moisture across East China. You know, there's been a lot of flooding in parts of China this summer, with the, you know, the northward extension of their rainy season, or some kind of like pseudo monsoon activity. North of that obviously has been this anomalous high pressure, right? The reason why that rainy pattern in China has been so persistent is you've had this kind of stubbornly anomalous high pressure sitting probably between about what 40 and 60 degrees north, kind of like right in that area. So not only is there this lack of typhoons or the potential from some of those aforementioned wildfires, but then you've got this kind of persistent pattern. We've actually seen a similar pattern in North America, right? Warmth over cold, right? Warm anomalies in the northern United States compared to places like Texas or the Southeast. So a similar pattern in East Asia. And when you've got that persistent 500 millibar high, anomalous 500 millibar high to the north, you've got, very few systems coming off the Asian continent or recurving typhoons to kind of disturb that water. I don't know, maybe it's like a bathtub, it just heats up in summer under these circumstances.
Yeah.
Trying to pull up a map showing there's the positive height anomaly.
Hey.
That was just mentioned. This is averaged since July 15th. Looks like there's actually sort of two centers, well, three, but it looks a little weird on this projection.
Right. And then, you always have to, what causes, stable patterns sometimes in the summer could change in the fall too, right? So it could influence, maybe that SST pattern could influence in a different way as we get into the fall. I was just thinking like, not to get too far off, but I was thinking if we could go back to that SST for just one second. I don't know. Again, this is more getting out of my area of expertise. It's putting my sort of amateur hat on. But like, obviously there's a little bit of warmth off the Northeast coast or off the Northeast, Southeast Canada. But if we had those kind of anomalies or whatever, something similar, where my head goes, and I don't know if this is right, so this is more of a comment question. As we get into mid and later fall, where you start to get more into, where you get, more upper air activity, more systems coming down from Canada, you get more potential for storms, nor'easters, things like that. And would an increased, a natural baroclinic zone there with, much stronger warmth in the oceans than normally you would expect, with combined with the, troughs coming down from Canada, would that significantly impact the frequency or intensity of northeast storms? Or is that just, what I mean? Is it more of a longer term kind of impact and not something that's going to impact the pattern on a synoptic scale? Does anyone? And I guess obviously we don't have that in the Northeast, but then I was thinking, could we expect something like that off the Southeast Asia or East Asia coast, similar to how my head was thinking off the East Coast of North America?
I wonder if most of these warm anomalies, I think, are north of the Gulf Stream. And so it's actually reducing the baroclinicity in the ocean, I think. And, so you're warming up these cooled waters. And so, the key baroclinicity for a nor'easter is more from the Gulf Stream, the very warm Gulf Stream waters to the cold continent. So I don't know if an anomaly this far north would have too much of an impact. Maybe it would, right along the coast, maybe you get rain instead of snow, but I don't know if it would really impact, say, the strength of a storm. Whereas if the anomaly was a little further south and you were really indicating an extremely warm Gulf Stream, then that would really bump up the baroclinicity and therefore those baroclinic growth mechanisms that would give you a nice nor'easter. So, but that's just my wild guess.
It's it's an interesting point that you bring up, just the fact that from a macro, that might be too macro way of thinking about it, that sensitivity, if there is an influence on a seasonal scale in terms of the synoptic frequency and intensity of nor'easters in a meaningful way, it may be that you have to look at a much more specific area to enhance the baroclinic zone or whatever. That's good. Interesting.
All right, would anyone else like to discuss their forecast?
Dave, you're welcome to go if you'd like.
Maybe
Oh.
Dave had to run.
Maybe, or he might be on mute. I don't know if you're talking, Dave. Okay, maybe he did run. So I can do.
Dave, I'm here.
there.
Did you have a question? I'm kind of
I was going to say,
two conversations here.
If you wanted to walk through your forecast real quick.
No, I don't want to walk through it.
Okay, that's awesome.
It's just a number. It's just a number.
Fair enough. Fair enough.
Not getting tied to it. No, I don't have a strong feel for this week. This one was. These weeks continually be frustrating. They're very frustrating. You know, we are in this energy space, kind of continually, punched around by, the 10 years warm, really the almost the 20 years pretty warm, and then you're matching it against patterns that aren't really that supportive for population centers, and in some ways it's been quite wet. So the summer's been kind of a bit of a constant drag. Even though it's been exciting in energy space because there's a lot going on, there's a lot of moving parts globally with regards to potential supply and demand. The North American weather is, I'd say, in general, largely uncooperative. So I'm constantly being challenged this summer to kind of temper these forecasts. But the problem is, despite tempering them, you're still getting these spikes of demand, right? Like that was a big surprise last week in the Southeast, the verification, right? That, Atlanta going into the mid 90s, and many Southeast cities really spiking, right? That was in a kind of a sea of coolness. You're still experiencing that, right? Texas had it the week prior, I think. And, in amongst this cool weather pattern, you're getting these locations to spike. And like next week in the East, looks like we're gonna have another 3 or 4 day run. Those are becoming frustrating to kind of gauge, and they're all significant. In general, the market is poised towards heat, but you're just not getting it in great abundance. So it can only kind of excite the market so much. It's been a frustrating summer from that standpoint. That has no bearing on my number. My number is just a number. I went a little above Climo, a little hotter than Climo. I'm going to ride that to the very end, a bitter, disgraceful end of summer.
Yeah.
All right. So the other Dave, do you want to talk about your forecast?
Yeah, sure.
Before
sure.
we only have 4 minutes left. So
4 minutes. I would just say that I kind of feel the same way. I mean, we've talked about this a lot, and I feel like it's been a very difficult summer for all the reasons that we've discussed today and over the last few weeks. And I think Dave brings up a good point about the Southeast. I think I was moaning about this at the very start of our call, maybe before the video, where we were, I was on a video AMS call, and I was surprised. I heard a lot of people, oh, it's so hot, and so many of these people. I'm like, where do they live? And I realized, I didn't realize how hot the Southeast, because a couple of the people we were talking were in the Carolinas and Georgia, and then a couple were in California and this and that. And I'm like, wait a minute. The Northeast was the bastion of cool weather here. So I think that was just a good point about the regionality of things and how difficult that can be too. But the bottom line was what I mentioned here was I went with my sort of standard formula that I generally use, that I'm continuing to tweak. That's labeled there. And I mentioned, I think in my notes, that I thought about my gut feeling where I did put some thought into putting in a little bit of a fudge factor on the MJO. My interpretation of the MJO was, we're starting to see some movement currently into what historically, based on different metrics, including our little analog tool, have been sort of a warmer area, phase 2 and 3. But I hesitated for 2 reasons. One was just because anytime it seems like I've been doing a fudge factor this summer, it has not worked out. And maybe that's just my short-term memory and too much influencing the forecast. And the other factor, though, was when I looked more broadly at the OLR, the CPC kind of like OLR maps, I felt like there was still a significant residual, I guess you could say, enhanced area across the tropical Northwest Pacific or somewhere in the Southwest Pacific. And that concerned me, that you've got these dueling areas, and that phase 5, 6 and area, which, arguably maybe helped really influence and feedback on I'm speculating a lot, obviously not having done a strong attribution, but may have helped to sort of lock in that pattern in July, that maybe it'll still have more of an influence in August. So it's a long-winded me saying that I felt like I couldn't do better than my formula, so I'm gonna stick with my formula. But yeah, I don't feel great about things for this forecast.
And again, we do see the MGO did come in a little bit warm, but not all that much above the 30-year normal.
Yep.
All right. Any questions or comments about that? I guess with 1 minute left, we can take a quick preview at the coming verification period.
Oh no.
That's the wrong one. August 4th through the 8th. The forecast, as always, the CFS was cold. Where's climatology on here? So we actually had a mixed bag, but it looks like most folks were warm. So let's see how we're doing for the 4th through the 8th. Pull up the right thing here. So our look is back to basically the previous pattern of warm in the north and cool in the southeast and south central US. That seems to be averaging out close to 0, but let's see, how do I get the numbers?
Oh, at the WDD data. Yeah.
Okay, there we go. And I want to
Pop
scroll-
CDD. If you click on pop.
Oh, there we go.
CDD,
Yep. And do I have to
boy.
click somewhere to make it load?
Oh, there it is. The target fit. So 55.18. So slightly below. You see where it says near the top?
Oh, okay, there it is. And that, okay, I just had to scroll down. Okay, so we are, okay, yeah, it is coming in slightly below the 30-year normal so far, but there's some time for it to heat up, I suppose. But it looks like it's going to be, certainly it's going to be pretty close to climatology, it looks like, if not a little bit below as so far. So there you have it.
And just taking a sneak peek at the forecast board, I think Dr. Lupo may benefit well again from this forecast if it doesn't change. So he's on a good streak right now.
We just need to move more people to the Dakotas, and then it would be on the warm side. All right. Well, that's all I have, and we're out of time.
Great.
So,
Well, yeah. Thank you so much, Dr. Decker.
no problem.
All right. We'll see you guys soon.
Have a good
Bye-bye.
week, everyone.
Yeah,
Thanks, you too.